The rest are coming, sir.
Okay, so let's give them about 3 minutes ago.
Yes, sir.
It's okay. Nwosu, you are welcome.
Thank you, Prof. Good morning, sir.
Yeah. Dele, you are welcome.
Good morning, sir.
Yeah, you are welcome. Let's get one or two people. Oyin Consola, you are welcome.
Thank you very much, sir.
Yeah. So can you see my screen?
Yes, sir.
You are seeing it?
Yes, sir.
So we have to review what we did yesterday on CDM methodology. So who can remind us of key things that we discussed yesterday?
Good morning, sir.
Morning, how are you?
Fine, sir. So yesterday we discussed about CDM, Clean
What
Development.
is CDM?
Clean Development Mechanism Project.
Okay.
So, and we also talked about the criteria for CDM. So, sorry. We also talked about the projects eligible for CDM, and we discussed about some key elements of baseline methodology rather. So,
What is baseline? What do you understand by baseline?
Good morning, sir.
Morning, how are you?
Yesterday we said baseline is the benchmark of greenhouse gases emission that would occur in the absence of CDM mechanism, clean development mechanism project.
Any other? Any other thing?
We also discussed the approaches,
Okay, what are
the
they?
three main methodology of establishing a baseline.
Okay.
So we discussed three baseline approaches: the actual historical emission, which is the approach A, the emission from the most economically attractive alternative technology, that was approach B, and approach C, I can't remember this.
You have tried. Another person? No, went through about 20 slides. Talk about projects eligible for CDM. Nobody mentioned that. Can we talk about that? Projects eligible for CDM.
Okay. Projects eligible for CDM, where we talked about projects that are for renewables, or let's say projects that are focused on transitioning from traditional fossil fuels to either natural gas or renewables, and projects that
What will,
also
what is the focus of that kind of project?
to reduce green gas emissions.
Okay, that's what we have there. It will result in reducing emission of one or more of the following six greenhouse gases. Do you guys see that? Hmm? Can you see the slide?
Yes, sir.
This project activity may
Yes,
reduce
sir, we can see this.
greenhouse gases from energy use and production, fuel combustion and fugitive emission from fuel, industrial processes, use of solvent and other products. Then we talk about project as sequester. What do you mean by sequestration? What does
Hello,
it mean?
sir.
Yes.
Sequestration is the process of capturing and storing
Storing.
greenhouse gases.
Storing carbon, not carbon environment.
Yes.
It's not greenhouse, so storing carbon,
Yes, sir.
Okay. So I
From
think
the atmosphere.
yeah, sequestration, yeah. It's like store. I mentioned some of the projects. Renewable energy technology, CHP. So what is CHP? And I see that is one of the projects eligible for CDM. I can hear you. What is CHP? CHP. Unite. What is CHP? Nala.
Hello, sir.
Yes.
CHP is combined heat and power, and is a technology that generates both electricity and heat from the same energy source, and is also one of those projects eligible for CDM.
So there are two products, Abby.
Yes, sir.
We have two products from it. Yeah, that's okay. So talk about baseline. Baseline and its context in CDM. Can you still remember when you say baseline? when you are doing we said that the concept of measurable reduction is based on a comparison with some defined level of GHG emissions. Baselines like a benchmark, isn't it? That you are comparing. You have something on ground, and when you put in a facility, then you go beyond that or below. So that's a baseline for measurement. Is that okay? So talk about key concepts for baselines. Talk about key elements, baseline scenarios. Talk about type, A plus, A minus, L minus, L plus. Baseline approaches. We have 3 of them. We have baseline, emission in the absence of proposed CDM. We define your baseline. And we talk about additionality. What is additionality? Yes, I'm waiting. What is additionality? Oh, yes. Additionality. Orioluwa Oyekansola Lala.
Hello, sir.
Yes.
I remembered you said additionality.
What of baseline first? Baseline. We said that is the emission in the absence of the proposed CDM project.
Yeah, the
Then what
reference level of emission.
before the CDM project? That's okay.
Yes.
Then what is additionality now?
You mentioned that additionality criterion, it ensures that the CDM projects, it's genuinely results in the reduction of carbon emission
Oh,
beyond what would have happened without
oh,
the project.
oh. We talk about component of additionality that should be satisfied by a proposed CDM project. 2. So we're not going to leakage now. Leakage. The term leakage refer to emission occurring outside the project boundary that are directly attributable to the proposed CDM project activity and are measurable. Emission occurring outside the project boundary and that are directly attributable to the proposed CDM project. For example, emission due to transportation of biomass fuel to the proposed CDM biomass power project site are a project leakage. Do you understand that now? When you have, if you have a CDM project, biomass power, they produce energy, they produce heat, isn't it? But you have to transport the material from outside the boundary of that project into that site. So that's a leakage. Do you get it now?
No, sir.
Eh? You got it?
No, sir.
We talk about a leakage now, isn't it? When you talk about, CDM, you have a biomass plant, isn't it? In Germany, in America. A plant that is producing using biomass, using waste from agriculture, from agriculture, waste from agriculture, waste from farms, and they are producing energy, isn't it? That's a CDM project, Abby.
Yes, sir.
But you have to transport, if you are supposing, you have to transport the waste from farm to that place, and there will be emission. There are emissions that are attributable to that because of that proposed CDM project. You have to transfer your waste from somewhere to that place, isn't it? And that transportation of biomass, there will be emission due to transportation, and that's what we call leakage. That is not directly from the CDM project, but outside the boundary of CDM project. Do you get it now?
Yes, sir.
Okay. So the project boundary for the project is the physical site of the power plant. Therefore, the transport related emission are outside the project boundary. Do you get that now?
Yes, sir.
Are you sure?
Yes, sir.
Because it is outside the boundary of that CDM project. So transportation of biomass fuel is a direct consequence of the biomass power plant and therefore is attributable to the project. Now, so it is necessary to identify possible leakage in emission in the baseline methodology. If the leakage is measurable and significant, method, that is equations or formula, that's where the leakage should be presented in the baseline methodology. Then we have key criteria for establishing baseline. How do you establish baseline? Apart from the above mentioned key components of the baseline methodology, the guidance also gives key criteria for establishing baseline. These criteria are important to ensure that baseline is established so that the objectives of CDM are fulfilled. The two criteria are transparency and conservative estimation of baseline. Number one, transparency. The baseline methodology should be transparent in each step of its development. The transparency criteria require that the methodology should also be replicable by third party, based completely on the information provided with the methodology documentation. All data sources, references, and assumptions used in developing the baseline should be identified and properly documented. Transparency means You have a procedure and you follow that procedure objectively. Don't jump. Don't cut corner. Let everything be transparent. Let everything be live from one step to another, so that anybody outside want to practice it, want to see what you have done, can replicate it. You understand that one now? Transparency. Do you understand that one? That criteria.
Yes, sir.
When you say something is transparent, what you are saying is, apart from you, any other person coming from outside should be able to follow it and get exactly or very close to what you have got. Number 2, conservatism. Conservative implying that the assumptions and choice of parameters should be such that baseline emission estimated should be on the lower rather than higher side. The conservative aspect of baseline methodology is linked to choice of assumptions and key parameters. It is also associated with uncertainties in baseline scenario, that is, assessment of possible future measures whose outcome might be unknown at present. That's conservatism. Your assumptions and your choice of parameters should be such that baseline emission estimate should be on the lower rather than higher side. So the conservative aspect of baseline estimate is linked to choice of assumption and key parameters. One associated with uncertainties in baseline scenario, assessment of possible future measures whose outcome might be unknown at present. The conservativeness and transparency of methodology is linked to the choice of values for key parameters and the assumptions made. A number of assumptions with respect to various elements of baseline methodology and parameters, e.g., carbon content of fuel used in explicit equation, are likely to remain while developing the baseline methodology. The estimate of baseline emission will be significantly affected by these assumptions and parameters. Therefore, key parameter and assumption, particularly in terms of data sources, should be clearly stated and chosen so that they result in a conservative estimate. Key parameters, assumption, and uncertainty. Their identification also help baseline developers to check the robustness of the methodology and its appropriateness for the specific project for which it is developed. For example, the choice of emission coefficient for fossil fuel use could be project specific or generic for the country, region adopted from Intergovernmental Panel on Climate Change application. If reliable project specific data are available, that should be used to estimate emission coefficient. But if the country specific data are of low reliability and IPCC default values are the only available source of information, then the choice should be made. Keep in mind the conservative principle. If the methodology uses a particular method for estimating the emissions, for example, weighted average of emission from all the emission sources in baseline scenario, the underlying assumption behind the choice of weights used for averaging should be stated. The choice of assumption should be guided by conservative principle within the realms of a realistic assumption. Another important factor is how uncertainty in various key parameter values is addressed by the methodology. A baseline scenario includes certain assumptions about the activities and the projects or sector in the future. These assumptions introduce uncertainty in the estimated baseline. The methodology needs to highlight each and every possible uncertainty embedded in the baseline scenario. The identification of uncertainties is useful to minimize the impact of uncertainties on baseline. Hence, a baseline methodology should clearly identify uncertainty and include discussion of elements that minimize uncertainty. Now, we now have baseline for small scale. For small scale CDM. Projects. Are we together?
Yes, sir.
Yes, sir.
Are we together?
Yes, sir.
Yeah. We want to base for small scale project now. Small scale projects. There are projects that are small scale. So we want to see baseline for them now. So the 7th session of the Conference of Parties, COP, 7. So decided to facilitate implementation of small scale greenhouse gas mitigation project by simplifying modalities and procedures. The main objective of simplifying the modality and procedure for the small scale project was to reduce the transaction cost that simplify modalities and procedure for small scale project activity provide pre-approved methodologies for baseline and monitoring, thereby reducing the cost of developing a project design document. PDD, project design document. Project design document. So the modalities also allow small scale project developer to use the service of the same designated operational entity, DOE, designated operation entity. So for both validation as well as verification to further reduce the cost. Bundling or portfolio bundling of project activities at the various stages in the project cycle, that is in the project design document, preparation, validation, registration, monitoring, verification, and certification for a small-scale project is allowed. Such bundling reduces the requirement for preparing an individual PDD, project design document, for each project and the cost for monitoring, validation, verification, and certification. So the criteria and types of small-scale CDM projects. The criteria and types of small-scale CDM projects. The CDM Executive Board develops simplified modalities and procedure for the SSC project with input from SSC project panel. So the 8th session of the Conference of Parties held in New Delhi, that's India, in 2002, adopted the small-scale CDM project modalities and procedure. So we have eligibility, criteria. So to use simplified modalities and procedure for small-scale CDM project activities, a proposed project activity should meet the following criteria. Simplify modality and procedure for small-scale CDM project activities. Annex. Number one, it should meet the eligibility criteria for small-scale CDM project activities set out in paragraph 6C of Institution 17 Cap 7. If you conform to one of the project categories in Appendix B of the simplified modalities and procedure for small-scale CDM project activities. And 3, it should not be a bundle component of a larger project activities as determined through Appendix C of the simplified modality and procedure for small-scale CDM project activities. Small-scale CDM project types. The 3 agreed small-scale project types are: number 1, renewable energy project activities with a maximum of 15 megawatts. Renewable energy, 15 megawatts or less. Are you getting me when you talk about small scale CDM projects? Are you following?
Yes, sir.
So the guy who was interviewed last week, renewable, if you go to a community and you want to start a CDM project for them, you will targeting this kind of thing, maybe 15 megawatt or less, for them to be able to have access to energy. Number 2, energy efficiency improvement project activity, which reduces energy consumption by up to 15 gigawatt hour per year. megawatt hour per year. Number 3, other project activities that will reduce anthropogenic emission by sources and directly emit less than 15 kilotons. 15 of CO2 equivalent annually. Are we okay with those 3? Small scale
Yes,
CDM
sir.
project. Eh? Are we okay?
Yes, sir.
Okay. So we are going to consider some of these issues one after the other. So we now talk about renewable energy project activities. So renewable energy projects. Of plan, and it was expressed as actual load, average load. Now, the actual load factor of the plant will not be considered for specifying the capacity. A megawatt is defined as megawatts electrical. Wherever the capacity is megawatt peak or megawatt thermal, an appropriate conversion factor should be used to represent it in megawatt electrical. The renewable energy projects include projects based on renewable energy, sources such as solar, wind, sustainable biomass, geothermal that provide electrical, e.g., lighting, mechanical, water pump, or thermal needs of end user. The energy activities. The small scale renewable project types are further subdivided into 4 project categories by CDM executive board. project activities. So the small scale renewable project types are further subdivided. We have 1A. 1A, that's electrical generation by the users. Electrical generation by the users. B, mechanical energy for the user. C, thermal energy for the user. D, renewable electricity generation for the grid. Are we okay with this form? Are we okay with this form?
Yes, sir.
Yes, sir.
Electricity generation by the users. That okay? Electricity. You are generating electricity. Then we have mechanical energy for the user, thermal energy for the user, renewable electricity generation for the grid. No, they are not the same. Is that okay? The four are not the same. Is it okay?
Yes, sir.
Okay. Energy efficiency improvement project activities. Energy efficiency project activities. Now, this reduce energy consumption on the supply and or demand side by up to the equivalent of 15 gigawatts hour per year. We normally use year by 1 year, which is also equivalent to 15 gigawatt times 3.6 terajoule. So gigawatt hour is 54 terajoule. Energy efficiency is defined as the improvement in the service provided per unit power. That is project activity, which increase output of traction, work, electricity, heat, light, or fuel per megawatt input are energy efficient project activities. Energy efficient activities. Improvement. Want to improve energy efficiency. That's the strategy. So energy consumption reduction is measured in watt hours. It's referring to an approved baseline. Watt hour. Or you say kilowatt hour. What did I call kilowatt hour the other time we had it? What did I call it? Kilowatt hour. I'm waiting for an answer. What did I call kilowatt hour the other time? What did I call kilowatt hour? Mukuru, Lala, Onyekasola. I'm waiting. Oh,
Sorry, sir. What's the question, sir?
I say, what is kilowatt hour? We talk about the other time. What did I call it?
Hello, Prof. Good morning, sir. Hello, Prof. Hello. Hello.
I don't think he can hear you.
Okay, thank you. Thank you, Lala. Thanks.
kilowatt hour. What does it mean? Yes. Or you have forgotten. What is kilowatt hour? Lala. Uwosu. Jaba.
Hello, Prof.
Yes.
So kilowatt hour simply means is used to quantify the power consumed by an
And
equipment.
what do we call it? There's a name they call it.
Sir, is it
That's
tariff?
tariff, eh?
Units.
That's tariff. That's
Okay,
what NEPA
noted, sir.
uses. That's what they used to consume. Maybe we did some calculation the other time. To know how much NEPA will charge you if you are using about 3 components. Didn't we do it together? Maybe at the end of the class today, we still do that exercise. So that's tariff, that's kilowatt hour. Are we okay now?
Yes, sir.
So energy consumption reduction is measured in watt hours. Energy consumption is in watt hour. And let me repeat myself. And I said that 1 kilowatt hour now is a tariff. I don't know how much do they charge you in your community. Here, NEPA is charging around 100 naira per kilowatt hour. What did I say now?
£100 per kilowatt hour.
Per kilowatt hour. So that's energy you are consuming. And so if you have a heater that is 1,000 watts at home, that's 1 kilowatt, isn't it? Right? Eh?
Yes, sir.
If you use it for 1 hour, isn't it? That's 1 kilowatt hour, Abby.
Yes, sir.
If you use for 1 hour, so that is 100 naira, Abby. So
Yes, sir.
If you use it 10 times in a month or 20 times in a month, that is 20 times 100 naira, isn't it? That's
Yes,
how much.
sir.
That's how much.
2,000.
That's 2,000 naira. That's what they charge you, 2,000 naira for using your heater, which is 1,000 watts. You use it for 1 month. You use it for 20 hours in a month. So they charge you 20,000 naira for that. And if it's AC, if it's AC now, what is the capacity of AC you are using in your room, Lala?
1.5 horsepower.
1.5, Abby. 1.5 horsepower.
Yes, sir.
How many do you have?
1,
2.
3. Well, don't be afraid. How many do you have?
2.
2. You have 2, Abby. Answer me now.
Yes, sir.
You have 2, yes. So that is how many horsepower then?
3.
That is 3 horsepower, Abby. Answer me.
Yes,
Yes,
sir.
sir.
3 horsepower.
3 horsepower, yes. How many hours do you use per day? No, wait. 1 horsepower is what? Let's say 740, Abby, or 745. What? Do you agree with me? What is 1 horsepower?
746.
Seven
Well,
what?
can you 746? But we can go with 745, sir, for
Okay.
simplicity.
Is Lala getting that?
Yes, sir, I am.
Aha. So multiply 745 times 3 and give me answer. I'm
That's
waiting for you.
2,000.
No, it's Lala.
Okay, Lala. Okay. Yes, sir.
2,235.
Is that help us check? Oh?
Yes, it's correct, sir.
Eh?
It's correct, sir.
It's correct, sir.
Okay. So how many watts will be that?
Two 2.2 watts.
Eh?
Is
Eh?
255 watts, but in kilowatts is 2.2 kilowatts. 2.23.
2.2 kilowatts.
2.2 kilowatts.
2.235.
Lala, how many hour per day do you use it?
I'm not the one with 3 AC in my room. Oh.
No, two. We say 2, not 3. Oh.
Okay. Roughly 6 hours.
6 hours per day.
Yes, sir.
Per day. Okay. So
So
per day now. So 2.2 times 6. What do we have there?
$13.2, sir.
13.2.
Hours, Abby. What
Yes,
is that?
sir.
13.2 what?
Kilowatt
No, to be kilowatt hour, isn't it?
hour. Yes, sir.
13.2 kilowatt hour. And what is 1 kilowatt hour? Ordinary.
Yes.
Eh? So 13.2 times 100 will now give you what?
1,320.
1,320.
1,320 naira. Abi?
Yes, sir.
And averagely in a month, how many times do you put it on?
Every day.
Every day. So let's take 30, Abi.
Yes, sir.
So multiply that one by 30. What are you going to get?
$39,600.
39,600 naira. Abi.
Yes, sir.
If you are using ether, what is that in a month now?
Okay.
That's for the ether. What did you get for ether? We get 2,000 Abi per what?
We got 20,000. I think it's 20,000, sir.
Is it 20,000? Eh?
No, it's 2,000. 2,000.
Eh?
Okay, 2,000 daily.
Yeah, it's 2,000.
And so how much now? So in a month, we are told that she has a 1,000 watt. No, let's get it again. She has a 1,000 watt, just one, isn't it? And that one is if you use it for an hour per day. We have said is that's 100 naira, Abi?
Yes,
That's 100
sir.
naira now. Eh?
100 naira per day.
If she uses for 20 days
That is 2,000.
That's
2,000
2,000 naira.
per month, Abi?
Yes,
Yes,
sir.
sir.
So let's add 2,000 now to it. So how much is that now? 39,600 plus 2,000.
That should be
That's
40.
41,600. 700.
40 what?
1,700.
Where do you see 7?
For the AC is
39,000.
39,000.
39,600.
Yes, sir.
Then plus 2,000.
41,600.
41,600. That's conservatively, isn't it? No, we have to add other things, laptop, fridge, and all that. But now, this is what we get now. So this is how they get your consumption and what you are consuming. Is it clear?
Yes, sir.
So how much are they giving you per month?
My parents pays. I don't know.
You don't find out.
Yes.
It's good to find out, oh, so that if they bring a unreasonable bill, to be able to counter it. Huh?
Okay, I will do that, sir.
You can calculate yourself now. You do the energy analysis. Are we okay now? Is it okay?
Yes, sir.
So you know what is tariff now, and you know energy. So a lower consumption as a result of lower level of activity, e.g., decrease in production, is not an eligible CDM project activity. A lower consumption as a result of lower level of activity, that is, e.g., decrease in production, is not an eligible CDM project activity. Do you understand that one now?
Yes, sir.
Very clear? Yeah. That is, a project activity is eligible for CDM if it results in energy efficiency improvement, so that the same level of activity as a baseline operator is possible with the lower level of consumption of energy compared to the baseline. Do you get that line? Do you get that message? Do you get that one? Hello?
Yes,
Are
sir.
we on the same page?
Yes, sir.
Yeah. Lala, are we okay with this?
Yes, sir.
Nwosu, so I can go to the next page. Yeah. The small scale energy efficiency improvement project activity includes use of equipment that results in reduction of energy losses in transmission and distribution in energy supply industry. We have electricity generation and more efficient use of energy at the end users, households, industrial units, buildings. Let's try to explain that. Let's explore that now. We talk about energy efficiency improvement, include use of equipment that result in your house now. If you replace all the bulbs in your house, you replace them with low energy bulbs, 15 watts, 15 watts, instead of the incandescent you are using, maybe 100 watts, 60 watts, 20, 80 watts, and that will be using. If you change it to low energy, then yeah, that's energy improvement. You have reduced amount of energy that you are consuming. Is that okay?
Yes, sir.
Is that okay? If you are using security light, about 10, and each of them is 150 watts, how many watts is that?
$1,500 watts.
That's 1.5 kilowatt, abi? Eh?
Yes, sir. Yes, sir.
Of Now, if you reduce them, if you reduce it to the low energy, we have low energy one that we are as bright as this, isn't it? If you reduce that to 50, so you have 50 times what? Times 10. What is
Times
that?
10,
Times 10. Yes, sir.
500,
500 watt, which is
500
0.5,
watts.
isn't it?
0.5.
0.5 kilowatts, Abby. So you have already, that's what we call energy improvement, isn't it? By your action, you have reduced energy consumption. Is that okay?
Yes, sir.
Are you okay?
Yes, sir.
Then reduction of energy losses in transmission and distribution in energy supply industry. You know, we said that when you produce in the power station now, when they produce and they transmit, if they produce 1,000 units, isn't it? The only one that can get to the consumer, they will lose 10% along the line. Maybe we say something like that.
Yes.
Uh-huh. If you put in something that will now reduce, that will bring down the losses, is energy improvement. So, and then a more efficient use of energy at the end user, at your hand, when you are using energy efficiently, then that's energy improvement. Have you been to hotel that you can in your house? There are some energy thing that will come up when it is dark, isn't it? Instead of coming up all the time, they will just come up when you enter your room. They will come up. When you are going out, they will go up. So you are reducing the energy that you are using. So the small scale EEI project are the following categories as defined by CDMEB. Number one, supply side energy efficiency improvement, transmission and distribution. Supply side energy efficiency improvement, generation. No, in transmission and distribution, you can improve energy there now. You can have energy improvement. Is that okay? I've said it. Then in generation too, you can have improvement there. Then C, demand side energy efficiency program for specific technologies. Then D, energy efficiency and fuel switching measure for industrial facility. Who can help us to explain that one? Nwosu, Omikasola, Lala, Peters, Tunde Jaba. Who will explain that one? Fuel switching. We have mentioned it. I want you to explain it. I'm waiting. Oh. Hello.
Hello, sir.
Who will explain that one? Energy efficiency and fuel switching measure for industrial facility. Yeah, who will try?
Hello, sir.
Yes, I can hear you.
Do they mean switching to cleaner energy source?
And explain it. How would that qualify for energy improvement? I'm listening. If you switch from solar to, if you switch from diesel to solar, are you not going to say, are you not saving energy?
You are, sir.
And that's switching. That's what we're talking about now. That for you can do that for industrial facilities, isn't it? Instead
Yes,
of
sir.
using diesel, you can change to other fuel. Abi? Then energy efficiency and fuel switching measure for buildings. You can switch to for building and you save energy. The energy efficiency and fuel switching measure for agricultural facilities and activities. Yes. No, agricultural facilities, you can switch fuel to, isn't it?
Yes, sir.
Okay. So other emission reduction projects. Other emission reduction projects. The project under this category are to satisfy two conditions. One, project actually result in lower GHG emission than in the baseline. Number two, total project emission itself should not be greater than 15 kilotons of carbon dioxide equivalent annually. Are those two conditions clear? Do you get those two conditions? Are they clear for emission reduction project?
Yes, sir. There.
Okay, so that's good. Then, I want to give an example now. A methane capture project from coal mine will be eligible under this category if the CO2 emission, that's equivalent now, from combustion of captured methane, are lower than the baseline CO2 emission, and the CO2 emission of the project should be less than 15 kilotons of CO2 equivalent. So if the CO2 emission from combustion of captured methane are greater than 15, the project cannot be considered as a small-scale project, though it still might be an eligible CDM project. So CDM project activities under this category will include agricultural projects, fuel switching, and you know what is called fuel switching now?
Yes, sir.
Okay. Then industrial processes and waste management. The way you manage your waste too can cause imbalance in the environment, can help the environment, isn't it? The way you manage your waste. You can process your waste before you dump it. So when you dump it, you can start producing methane from it. So there are the way you manage your waste too is very important. Possible examples in the agricultural sector include improved manure management, composting and all these things, reduction of enteric fermentation, improve fertilizer usage, or improve water management in rice cultivation. Is that okay?
Yes, sir.
So then other project activity that will qualify under this category include CO2 recycling, carbon electrodes, adipic acid production, and the use of hydrofluorocarbons, perfluorocarbons, and sulfur hexafluoride. The CDM EB has yet to suggest appropriate baseline methodology for this project. Now, the type 3 project includes following categories as defined by CDM EB. Type 3, we have agriculture, we have switching fossil fuels, we have emission reduction by low greenhouse gas emitting vehicles, we have methane recovery, we have avoidance of methane production from biomass decay through controlled combustion. A, B, C, D, E. Are we okay with that by 3?
Yes, sir.
Now, the type 3 project include following categories are defined by CDM EB. If the CO2 emission from combustion or capture methane are greater than, the project cannot be considered as a small scale project, though it is still might be yes. So CDM project activity on that category could include Accra project, West switching, industrial process, and mention that. Energy baseline. Energy. Energy baseline. The simplified baseline is the fuel consumption of the actual technology in use. If the project is a replacement project, if the proposed project is entirely a new installation, the baseline, the amount of fuel that will have been used in the absence of the proposed project activity. The project participant have two options to estimate the energy baseline. The first option, option 1, is based on the energy consumption of consumers, whereas the second option is based on the energy output of project activity. Option 1, energy consumption. How do you measure energy consumption? As I just said now, who can remind us? How do you measure it?
Hours.
By taking the audit of the equipment you are using at home, the power audit of them.
In what unit are you going to get it?
Hours.
Kilowatt hour, not hour. To mean kilowatt
Hours.
kilowatt. That's the tariff. That's the energy. What is the unit of kilowatt?
The tariff.
That's joule per second, Abi. Kilowatt is joule per second, isn't it? Kilowatt is joule per second. Kilowatt is joule per second. Kilojoule per second.
Yes, sir. Joule for seconds for the time. Joule per second, sir. Yes, sir.
Then 1 hour. What is 1 hour? That's 60 times 60, Abi. 1 hour is 60 minutes now, Abi.
Yes, sir.
So what is then 1 hour? What will be 1 hour in seconds?
3,600.
So kilojoule per second times second now will now give you what? Kilojoule per second times second will give you what?
That's
If you-
kilojoule, sir.
That's
Eh?
3.6 million.
Kilojoule per second times second will give you what?
Kilojoule, sir.
They give you kilojoule. That's energy consumption, isn't it? You consume energy in terms of kilojoule, Abi. I know somebody. So that's your kilowatt hour. That's what it translates to. It translates to energy you are consuming. So this is energy balance in this option is calculated as EB now. Summation of I NI dot CI minus I. So that's a question. EB is annual energy baseline in kilowatt hour per year. Kilowatt hour. Kilowatt hour per year. Are you following? Are you following?
Yes, sir.
What is EB?
Annual energy baseline, kilowatt hour per year.
Per year, in 1 year. In 1 year, that's our baseline now. And that's what is that kilowatt hour? That's in joule, isn't it? That's energy. Are we okay? The summation I is the sum over the group of I renewable energy technologies, e.g. residential, rural health center, rural school, may, water pump for irrigation, a major part of the project. You know, in a community, are you listening?
Yes, sir.
In a community where you want to have rural, renewable energy, you have to supply energy to residential, yes or no?
Yes.
You have to supply to rural health center, yes or no?
Yes.
You have to supply to school, Abi.
Schools. Yes.
Schools, the mills where they are grinding, then if they are pricing irrigation, they have a water pump for irrigation, isn't it?
Yes, sir.
So those are the I. It may be 5, maybe 6, maybe 10, maybe 20. So NI now. Number of consumers supplied by installation of renewable energy technology belonging to the group of I. Renewable energy technology during the year. You must know the number of your consumers now, isn't it? Abi? You must know those who are consuming your products that you are producing.
Yes, sir.
You must know their number. So that's what we call that. Then energy baseline, then CI now. CI, estimate of average annual individual consumption. Estimate of average annual individual consumption. Do you understand that one now? For household, you know that. Like we calculated for Lala now, that you are going to pay 49,000 naira. Another person for individual per year. If you have 20 of them, you have to calculate per year, isn't it? Average annual individual consumption. The one they consume in school is different than the one they consume in residential. The one they consume in residential is different than the one they consume for irrigation. Are you getting it? Now, are we okay with that one with CI? If energy consumption is metered, CI is the average energy consumed by consumer belonging to the group of high renewable energy technology. Are we okay?
Yes, sir.
So L now, that's average technical distribution losses that will have been observed in diesel power mini grids installed by public program or distribution company in isolated area, expressed as a fraction. Expressed as a fraction. So we have defined all the terms now there. Option 2 now. Option 2. The energy baseline in this option is calculated as EB I over 1 minus L. EB is annual energy baseline in kilowatt hour per year. Summation I, the sum over the group of high renewable energy technology, solar home, system, solar pump, implemented as part of the project. OI is the estimated annual output of the renewable energy technologies of the group of I. Renewable energy technology installed in kilowatt hour per year. Then L is or I, average technical distribution losses that will have been observed in district power may decrease installed by public program or distribution company in isolated areas, expressed as a fraction. That's option 2. So the energy baseline will be based on either data on electricity consumption or similar household in other villages that are connected to the grid, or the baseline energy consumption will be estimated as the expected energy output of solar home system installed under the project. In this example, solar home system provide lighting needs of households. The electricity consumption of lighting of small similar household in grid connected village will be used as the energy baseline. Let the estimated annual electricity generation per SHA be 200 watts in the example. 200 WP in the example is 0.146. So let's say for solar home system, 0.146 megawatts hour. What is that? 0.146 megawatt hour. What is that? What is megawatt? What is megawatt?
That's 146 kilowatts.
What is 1 megawatt?
1,000 kilowatts, sir.
And
1,000 kilowatts, sir.
okay, that's 1 times 10 to the power 6 watt. I mean,
Yes, sir.
Abby?
Yes, sir.
So WP now is 1 watt power generation by a PV module at an additional level of 1 kilowatt per meter square at 25 degrees Celsius. So total estimated electricity generated from 10,000 will now be 10,000 times that. That's 146 megawatts. You want 10,000 of that. So we are going to have 146 megawatts hour. If the display loss was 10%, if the display loss was 10%, then energy baseline will now be what? EB. Summation 146. Is that right, Abby?
Yes, sir.
Are you following? Then 1 minus 0.1 because it's 10%. 10
Yes,
over
sir.
100 is what? What is 10 over 100?
0.1.
0.1.
Lala, what's 10 of 100?
0.1.
So now 1460 divided by 0.9, Abi. And that will be equal to what?
One six two two.
That is our EB, Abi.
Yes,
Energy
sir.
baseline. 1,622 megawatts. Now we have one exercise now. So assuming we have 20,000 households. And then our average user loss. Average is 0.75. Oh, sorry. Is is 7.5%. So what's our EB? Do you get it now? Hello?
Hello, sir.
Yes. So
What
calculate
was the distribution loss?
20,000 household. Everything remain the same. Then average user loss is 7.5. So what is EB?
$3,157 megawatt hour.
Do it well. That's your whole. Write it down.
Okay, sir.
I'm waiting for now.
What was your question, sir?
Eh?
What was your question?
No, somebody has, he said 20,000 household. Average user loss is 7.5%. What will be the EB? Somebody has got in. I just want to, so
3,893, sir.
Okay, that's your own. Write it down. So 3,000 what?
893, sir.
3,001.
Anyway. 3,893, sir.
Okay. Lala, what's your own?
$3,057 megawatt hour.
Okay. Any other one? Any other attempt? What of Alaoye? What's your own? Jaba. What? How do you take it? But I haven't seen that. What do you want to do then? For who? Okay. Get up. Stop. No, just hold on. You see this with me. Jaba. Any other answer? Any other answer?
Sir, my network is messing up terribly. I only heard the 20,000 parts. I didn't get the rest of the question. I just
7.5%. 7.5%. That's division losses.
okay. So what are we asked to calculate?
Sir, did you say 7.5 or 0.5?
Energy baseline. Eh?
Did you say 7.5 or 0.5?
7.5%. 7.
Wonderful.
Okay.
7.5.
So 7.5% loss then, 20,000 SHS.
Household.
So okay, all right, cool. I'm coming. That's 3,156 megawatts, sir.
Write it down.
3,156 megawatt hour. Yeah.
And write it down.
Okay, sir.
Hello, Prof.
Yeah, I can hear you.
I got 3,156.75.
Okay, 150 what?
3,156.7. Okay, 76.
Okay, round it up.
3,157.
Megawatt hour.
Yes, sir.
Okay. So let's see another one. Yes, another version. Any other attempts? So the EB is 20,000 times 0.146 divided by 1 minus 0.075. Is that right? That's
Yes, sir.
290 over 0.925. Abi? That's
Yes, sir.
3157 megawatts hour. Is that okay?
Yes, sir.
Yes,
So
sir.
anybody who gets any different thing is 3157 megawatt hour. So that is it. Is that okay?
Yes, sir. Yes, sir.
That's the energy baseline. If you don't get it, just do it again and then make sure you get it. So we are coming to the end of the class. So our next class is Monday, Abi. 10 to 11. Abi?
Yes, sir.
Okay, so we'll meet. That is great. I will send have I sent this one to you?
No, sir, we haven't
No,
received
sir.
this one.
No, sir.
I will send it. So bye.
Okay, thank you. Yes, bye
Yeah.
for now, sir.
Thank you, sir.